Greetings, everybody. So I am Sergey Karpov. This video will be about one of the components which maintains omnipresence in virtually all of the projects that have been done in the past few years. And that is the backend ASP.NET Core REST API server. So REST API Uh, that it usually also is connected to the database, providing a CRUD operation upon the database: create, read, update, delete. The REST server itself supports, of course, all the HTTP verbs: get, post, put, delete, patch, and it is accessible through HTTP endpoint. Usually it's a HTTPS endpoint at that. I have been doing projects with the REST API services for quite some time, but it all came together about early year 2020 with .NET 3.15, ASP.NET Core, dependency injection, the cache concept, the HTTP client concept with the factory, the configuration aspects, and the hosting. So all these aspects were put together, and I started the development and research in the optimal coding and design solutions for ASP.NET Core REST services at that time. I have taken a route of creating libraries, reusable libraries that could be used as a base for multiple services as long as the necessity was coming. I think it was a correct approach. I have been doing this ever since, moving through .NET version 6, 8, and now 10. So at the time frame of 2021, there were few services that I created based on using the result of my R&D and the libraries that I put together. And right now there are a few dozen of successful services providing REST APIs and CRUD functionality are running with different clients around the world and providing satisfactory results and a very high level of availability. I think I reached, if not 5 nines, but at least 4 nines in terms of availability rating. Here we see two instances of Visual Studio uh, with two solutions opened. One solution is dedicated to Web API REST servers for .NET 6 and the other for .NET 8. So the structure of the solution and the project, if anybody cares to take a look what it is very similar in both. So we try to keep things simple. So we have a core uh, components, two assemblies. We have domain components, two assemblies, the entities and the logic. And of course the target, the executable assembly is this one, Web API REST server. Let me switch to a diagram, how this all is architected. So this is a diagram, and our target again is right here. So this is the main culprit for this effort. REST API server. REST API server is built with a domain-driven architecture, where domain is comprised of three components, two of which are .NET assemblies, the domain data and domain model, and the component number three is the database. So this is the database with a bunch of tables sitting on the Microsoft SQL Server or any other kind of SQL Server that you might imagine. Now, these three funny rounded rectangles with question marks, they are clients. They are clients that are sitting and they depend on the data that is provided by this REST server endpoint. The clients are usually are JavaScript-based UI components like React, Angular, and Vue, for example, and they're using their internal fetching capacity to retrieve data from the server, usually in asynchronous mode. Let me start the servers. I will start both solutions, both servers at the same time. So I'm starting the order doesn't really matter. It's not important. So we have these are console applications, of course, the servers. And after I adjust the visuals, we should be able to see both servers in action, how they started. So all this text is the log. This log goes into log, and it's also displayed on a console itself. So from this log, we see that we see a few things that are interesting about how the servers are architected and designed. So, for example, we see that servers, they have the library assemblies that they depend on. So, and here we see two core assemblies and two domain-specific assemblies. The same thing here. So the server is here. Now in assemblies, I am taking a trouble of actually capturing their runtime version. So for example, here we see that core lib is standard 2.1. So it is exactly the same lib in both, because it is compatible with both .NET runtime. Whereas the other core lib is specific to a specific .NET runtime. So it's 8.0 here and it's 6.0 here. Because there are differences in how ASP.NET Core was implemented over the years for different .NET versions. So I had to separate these libraries. And the same thing is done for domain assemblies. So there is a one domain assembly which is very simple. It only has DTOs or entities, data transfer objects, which have nothing but properties, and it only depends on interfaces abstractions that we see in a core. But the domain logic assembly has certain functionality that is specific for a specific .NET runtime version. So we have two servers. Of course, they are listening on the local host endpoint. Let's see where this endpoint is. And I need to scroll a little bit. Bear with me for a second. So this server is listening on this HTTPS endpoint 4412. Right, the other server is listening on the other endpoint. Take my word for it. This is 4412 and the other was 4422. our client is React website. So React website is connected to localhost, and so in this config we specify to which server it will go for the data. So I will restart React locally, and let's see what can we take from it. Uh, the server actually was accessed, so we gotta get HTTP GET request, and this GET for orders, and so this React website, it has it's built in like a dashboard fashion, and it has the order table. Now it also has another hook here that if I select an order, it populates the bottom table, which displays a deal structure. So each order has its separate deal structure. So here we see that order number 8 has 2 deals in its structure. The order number 9 has nothing, and this guy has 7 deals. So uh, everything goes into the top server, which happens to be, I think it was 6 on the top for that net 6. But since both servers are sitting on the same database and they have exactly the same API, they are interchangeable. So a client can go to the other server if there is a need for that, and we can try to demonstrate that as well. So if I change the base address here just by switching for the other server, and then I restart React app, see what we get here, and bingo, we we get requests for the bottom server. So now we have a couple of get requests for the bottom server. Now let's see what they have 182 customers, and we have 77 products. So we issue this CRUD request to the database, which are wrapped into REST verbs that React can understand, and it's all done asynchronously. Well, take my word for it. I'm not going to dig into JavaScript code right now. Uh, and it actually and it works. So both servers are fully functional CRUD servers. They can be deployed remotely, of course. Right now, of course, they're very fast because they're just sitting on the same machine. But they can be deployed remotely. It has been done multiple times. Again, as I mentioned, this particular code base has been used for many successful professional deliveries. And wrapping up the presentation, that's my point. So the technology for building um, web API REST servers and the technology that is producing the CRUD functionality on a database is not very complicated. I will open the project one more time just to show the structure, just to dig a little bit into the structure of the project. So here we see the program.cs. So this is this file, and it's a main file in our the application, the target. So this other 4 assemblies are libraries. So this is the executable assembly. Now, if we look into into this one, we can see that there is a folder called ASP.NET. So ASP.NET, it encapsulates the common functionality for everything ASP. We can see that we have ASP.NET Core class, we can see Blazor specific, we can see hosted service specific, we can see Web API master, Blazor master, socket server master. So these classes, they cover the core functionality for all variations of ASP.NET Core server components. We can create a Blazor component, we can create a invisible hosted service that runs in the background. We can create this one is used for this project. Obviously, it's called Web API App Master. Uh, and we can create a web host, web socket server that would support the specifics of the WebSocket application. Now, if we look at this library, we see that it has, again, a bunch of folders. They're not very densely populated. So the important are the gateway. If we look at the gateway, it becomes clear what it does. So we can access data lake data. We can access CSV data. CSV data. I'm sorry. We can go to the HTTP. We can have SQL access in two ways. We can use ADO.NET and Dapper. So these both libraries have been developed some time ago. Again, they are very well tested, have been used. Right now the Dapper is used. So my latest preference was to use Dapper for the reason of simplicity. It's actually the code in Dapper is substantially simpler than if I write a code in a bare ADO.NET. And there is this interesting folder called master, and it has, for example, data access master. So this class encapsulates functionality for CRUD. So this class, it uses the SQL adapter, and it goes into this SQL database of any kind. It's all dynamically configured, by the way, and it provides all the CRUD functionality. So create, update, read, delete is handled by the code in this this library, which means that if we go back here and take another look at the diagram, we see that this is what I just described. So all the core components in these two core assemblies are here, and they're gateways, hosting, operations, and they are connected to everything else through abstractions. And the domain, therefore, becomes very small. It's about like probably 5–10% of the code that is involved in supporting the CRUD operation is in domain, and another probably 2% of the code in the implementation of actual REST server. The result, everything works. So we have a completely functional solution. The fact that there is a great percentage of code reuse means that it's very robust, and the development time is negligible. So we can produce a professional grade REST API server very quickly. That's and on that note, I will conclude my presentation. Thank you very much.